Hello, this is Mr. Win, and this video is about logic, reasoning, and proofs part 2. So inductive reasoning is where you use a small number of examples to try to find a pattern that you see, and then you generalize that into a conclusion. Think of it as starting specific and ending broad. Here's an example. We see all these squares. How many little lines do you see? So here's 4 little lines, here's 8 plus 2 more is 10 little lines, and 18 little lines, 20, and then 40 lines. It keeps going. So I noticed from 4 to 10 you had 6, from 10 to 18 you had 8, 18 to 28 you had 10, then you had 12, but it keeps increasing by 2. Alright, so I would assume the next one would be at plus 14. So 4 plus 14 is 54 segments. That's my conjecture based on this pattern. And if I do draw it, I do actually would, and you count it out, it would be 54. So that's inductive reasoning. Deductive reasoning is where you use generalized principles that are known to be true, such as facts, rules, definitions, and properties, to then reach logical conclusions from given statements. Think of it as starting broad and ending specific. Alright, now while one counterexample is enough to disprove a conjecture found by inductive reasoning, it is not enough to prove the conjecture, as you have to list every single possibility, which is too much to even attempt. So inductive is not good for proving. To prove something requires deductive reasoning, since it's based on pre-established facts that everyone can agree on. It does not require guessing and will be mathematically correct with sound logic. So the law of detachment is a form of using deductive reasoning. As long as the facts given are true, then any conclusion reached using deductive reasoning is also true. So if P implies Q is a true statement, and P is true, then Q will also be true. So here's an example. It says, if a car does not have gas, then it will not start. Well, that's a true statement. Or then I would say, hey, Ryan's car does not have gas. So what can you logically conclude? Usually we'll say, well, Ryan's car will not start. So given a true fact P to Q, and then we've got another P, we can give the Q. So think of it as inserting a specific person's name into a universally accepted fact. Be careful of the ordering as it must follow the original conditional. So here's the other one. The converse is not necessarily true. Y'all know that from before. It's not logically equivalent as the conditional. If Ryan's car did not start, that doesn't mean it didn't have gas. Although that's one possibility. Maybe he had no battery installed or he had no keys with him. Alright, so it must be P to Q with another P. Alright, the law of syllogism is another form of deductive reasoning. It allows you to draw a conclusion from two true conditional statements where the conclusion of one is the hypothesis of another. Alright, so if P to Q and Q to R are true statements, then we can do P to R. That will also be true. Here's an example. If you study a lot, then you'll pass your classes. If you pass your classes, then you'll graduate high school. Alright, so here's P to Q, and this Q is the same as this Q right here. So there's Q to R. So what I'm going to do is I'm going to cross out or simplify the Q part, and just say P to R. So if you study a lot, then you'll graduate high school. That's also true. So think of this as combining or simplifying multiple parts by crossing out or skipping the repeat. Be careful with the ordering as it must follow the original conditional. It must go P, Q, Q, R. It can't go P, Q, R, Q like that. Alright, and that's actually it for this video. Hope you enjoyed it. See you soon. Thanks for watching. Bye.